yesterday would have been at Wednesday. I want to remind everybody that you should not have your electronic devices out. Thanks for putting them away. No AirPods, no earbuds, no phones. We want to make sure that we've got our full attention, because we want to make sure that we're giving ourselves the best we can do, right? So that at the end you don't say, oh my gosh, I can't do science, and I say, yes you can, if you just give me your full attention.
100%.
Right, so get your notebook out. All right, today's your capture question. It says, what do you think is the difference between cohesion and adhesion when we're talking about water? It has a lot to do with biology and chemistry, which you are going to be moving into next year. So if you were not here yesterday or the day before, we need to make sure that we get you one of these labs. Can you give that to Lexi right behind you? And make sure that you have your lab out as well as the notes that you picked up on the way in. Because today we're going to go over the capture question, then we're going to go over the lab on water properties while going over those notes, and then hopefully we'll have time to work on the conclusion paragraph, but I'm going to talk about that at the beginning of the hour so that you know what is due in my class by tomorrow. Just to let you know, conclusion paragraph for the lab is due tomorrow, and again, we're going to go over that today with notes. Quiz on water cycle is probably going to be on Monday. Your final exam is next Wednesday. Sorry, that's not February 1st, it's March 1st. So next Wednesday is your final exam. That's because that gives us Thursday for the retake, and then you guys are off on Friday, and the trimester is done. So, yeah, and so then it's like your second grade trimester stuff, that's it. So as your grade is now, that's probably pretty much your last point of like, hey, how can I get my grade up, is going to be that exam. So we have to really focus on that. I want to ask you, I've got some parts missing for the model that we had on table 1. I borrowed this from the chemistry department, and so if anybody sees any of these, no questions asked, I just need them back. I had like 12 of them, and now we only have 7. So I need these, and then I'm also missing some of these. Why are you smiling? Do you know somebody who took them? Well, then it looks like you do, so we'll have a conversation. These are missing, so I need to have them back. Again, I borrowed them from a colleague, and it makes us look bad, as a class, and so we just need to make sure we have those back. If you know of anybody, or if anybody has them, just return them. Ask the office to put them in my mailbox, whatever. But I'm embarrassed right now for us as a 9th grade class that somebody would have walked off with those. All right, enough said about that. I'm going to be quiet for 1 minute. You be quiet for 1 minute, and if you could please write this down, let your lab help you. That'll give you an opportunity to take attendance. Okay. All right, I was going to put a minute on the clock, and our time starts as soon as I find my phone. You know when you try to do so many things? Has anybody ever tried to do so many things at once, and you just kind of get lost in the shuffle? Anybody? Thanks, man. You get lost a lot, don't you?
Yeah.
I respect that about you. All right, let's go ahead. I'm going to give you some time. On your marks, get set, go. I'm sure I left it somewhere. What's your question, Ellen? Yes, absolutely, 100%. You can look at that. Oh no, he was ill. But Lexi's back, so that's a win. And has anybody seen Billy today? They're here? They are? Maybe they're in the nest. All right. Let's go ahead now with our pair share partners and turn and talk that out, please. I'll give you a 5-second countdown to go ahead and talk that out. And your time starts now. Ready, set, go. 1, 2, 4, 3.
Yeah. Adhesion means
It's the same lab. All right, 3, 2, 1, and we are done. Somebody help me out here. Where do you want? How about this? We've got 2 words here. We've got cohesion and adhesion. We have both of them go with this thing, hesion. Do either one of them Do either one of them sound familiar where we might be able to figure the other one out? Like, does cohesion remind you of something? Does adhesion remind you of something? Turn and talk that out with your partners. You've got 5 seconds, ready, set, go. 5, 4, 3, 2, 1. And we are done. Raise your hand, somebody maybe who doesn't usually participate. Okay, Will, can you turn a little bit, bud?
So cohesion, I reminds me of the word coworker.
Coworker, oh, cohesion, coworker, I like that. I'm gonna start with that. So let's go ahead and write down cohesion. Kind of reminds Will of this idea of a co-worker. I would agree with you on that. I like that. And so when we talk about cohesion, co-worker, it kind of reminds me of combined.
Yep.
So I'm going to write down the word combine. And what do we think that means then in terms of water? Yeah, it sticks together with what? Itself. So this is when water molecules stick together with other water molecules. So it's like they're combining or they're co-workers. They are sticking together. So water molecule and water molecule. An example of this would be if we see like a rain droplet, or I'll say water droplet. Water droplet would be lots of molecules sticking together to form one larger water droplet. Thousands of water molecules through the process of cohesion sticking together. This is what makes surface tension really great. So if you were able to put paper clips on top of the water, how many of you were able to get a paper clip to be on top of that water? Yeah. If you're able to do that, then that means that, water is holding on, like we're all connecting arms as water molecules and we're holding up this thing, which normally we shouldn't be able to hold up. But we are because of the cohesion of the molecules. Now, adhesion, what does that sound like? What does that remind you of? Turn it again, bud. What's adhesion? Go ahead, Lexi. Adhesive. I love it. I'm going to go ahead and write that down here. Adhesion would be kind of like adhesive, right? And what's adhesive mean? Yeah. Yeah, it's like sticky. So if something's got adhesive qualities, it's got sticky. And in this case, we have the water molecules, that's nice spell molecules, molecules sticking to other surfaces. Not each other, we don't talk about it in terms of adhesion of its other surfaces. And so an example of this would be like a water droplet on your window. Water droplet on window. This is huge in what's called capillary action. Or if I say, hey, when we are using a graduated cylinder and water, right, is sticking to the sides like this, and I say when you are looking at measuring it, you always need to look at the bottom of the meniscus. This is like your little eyeball. Those are your little eyelashes. And I say, look right here at the bottom of the meniscus because the water is adhesing itself to the sides, and it kind of goes like that. Surface tension is why when you were dropping those little droplets on top of the penny, it was able to bubble up. That's because those water molecules are hanging on to each other. Adhesion and cohesion. How's that feel? Some of us didn't write anything down. What else? It's absolutely fine. Some of us did write it down. What we're going to do now is we're going to go ahead and go over our notes that you picked up on the way in. At the same time, we're looking at our lab. So could you please make sure you get the lab out from Monday and Tuesday and the notes that you picked up on the way in. The first thing I want to do on that lab is go to the very back page because I want you to be able to see what your paragraph is going to be. This is what you are going to have tonight for homework. So, if you could please go to the very last page in your lab, the very back page. It looks like this. I'm going to turn down the front lights. Sai, if you have any ability to contact Michaela sometime tonight and just kind of let them know what we're doing. Also, I'll post this video online. Okay, so it says your conclusion is going to be a 4-point paragraph. It says, please write me a well-formed paragraph and answer the following question. I would make this your topic sentence, right? That would be like sentence number 1. I would say, water is one of the largest forces for changing the surface of the earth that we know of, right? That right there is your topic sentence. So for me, that's what I would do. And for those of you that are savvy at this, you've got your pencils, right? I would say TS, topic sentence might be right there. Good one. Second sentence, I would, because it says, pick 2 properties of water that you think are the most important for shaping our earth. There's sentence number 2. I would say 2 properties of water that I think are the most important in shaping the earth are, and then you're going to pick 2 of the properties from the lab, right? So I would have this be sentence number 2, right? So this is topic sentence number 1, and then I would say, the 2 properties that I think are the most important are, blah, blah, blah. And then give me 2 of them. Sound good so far? Then what you're going to do is you're going to explain how each of those properties works with evidence from your lab. Do you understand? So if you think adhesion is a very important property of water, say, the first one I want to talk about are, the 2 properties are adhesion and cohesion. And then you're going to go into the next sentence, which would be, adhesion is, da-da-da-da-da-da-da, explain what it is. This is why I think it's the most important because, and then you give me information. And then maybe one more sentence after that, giving some follow-up. And then talk about the next one. Sound good? Yes? Okay. You get a 4 out of 4 if you have a claim directly answering the question. If you provided examples as evidence, and the evidence is clearly explained, like why your evidence backs that up. Don't worry about the grammatical errors. I get it. I'm not a big speller either. As long as the science is good, then we're good. Good? So let's go over notes today so that we can make sure we feel good about each one of these stations. If I missed anything, if you have questions about anything, please make sure that you ask me as we are going through these so that you feel good about what it is that we are doing. Let me pull that up. All right, sweet peas, let's go over properties of water. This was just a title slide. You don't need to worry about that, but during this note session, what I hope that we figure out is how does water get from the soil to the leaves of a plant, right? Because that is a really good way that trees move moisture or water in the hydrosphere from the soil out to the atmosphere. Trees are a really good way of moving water in the water cycle. And then also a really big important part that we want to learn about today is what happens to fish when lakes freeze. Why is it, what special property about water enables it to float so that you don't have to worry about killing all the fish at the bottom of a pond? So let's go ahead and first look at this one. Okay, so this I believe is station 1. Can everybody please make sure that you are on station 1 on your lab, which you all should be. All right. So it says water is a polar molecule. What does that mean, polar molecule? For those of you that did station 1, it's the very first thing. What's a polar molecule? What is it?
It is a molecule that has charges.
Yeah, it's a water molecule that has charges. That was the very first thing. It's got a positive end and a negative end. So it's a water molecule that has a positive end and a negative end. That was the number 1 question on station 1. Does everybody have that down? All right. And so then what we have here is we've got a slight positive end and negative end. So the hydrogen, this plus sign means what? Positive. So I'm just going to write the word positive here. And this negative side means what? That means negative. So this is the negative side. Now, if you have a magnet, how do you get magnets to stick to each other? positive side to the negative side. So then water molecules are really good at, they have cohesive properties because of why? Because why? Think about this as a magnet. Turn with your pair-share partner and talk that out. Why are they so cohesive based on what we see here? Ready, set, go. Okay, so why are they so good at sticking together? Because they're polar, they've got a positive and a negative. And the positive end sticks to what end of another water molecule?
Negative.
The negative end of another water molecule. And the negative end sticks to what end of another water molecule?
Positive.
The positive. And so they're really good at arranging themselves, which you should have drawn a picture of, where we've got plus, plus, negative, and then over here we would have plus, plus, negative, and then this one would be like a negative over here, and we'd have a plus over here, and we'd have a plus over here, and then we'd have a negative over here, and then we'd have a plus over here. And so they're kind of always sticking together, you know, negative to positive, negative to positive, negative to positive, negative to positive. And so they're always kind of like forming themselves like that. Now, we'll talk about this later when we get to why they float, but they don't. Hydrogen bonds are what's called very weak bonds, and so they break very easily. Hydrogen bond means this. And so it breaks very easily, which is good because water then is able to kind of like conform to the space that you fill it into, right? Unless you freeze it. What happens when you freeze water? It expands because then these things get into place solidly. And we'll talk about that in a minute. So the slight positive charge on the hydrogen side makes this water molecule a polar water molecule, and it's very good for its cohesive properties. Now, non-polar molecules, like oil, are hydrophobic. What does that mean?
They don't combine with
Don't combine well. So we're going to say, do not mix with water. So non-polar molecules like oil are what's called hydrophobic. They don't mix very well at all. Are we good? No? Yeah? Basically, the first station just wanted you to think about water molecules like little magnets. Positive to negative, positive to negative. Good? Great. Let's go ahead and turn the page. Now, we're going to kind of look at using that information. Why is it that water molecules float? Okay, or excuse me, ice floats. The fact that ice floats is cited as a crucial property for maintaining life. So let's talk about this before we move forward. Why is it very important that ice can float in terms of a pond? So if this is a pond and I've got little fish floating in here, why is it important that ice floats on the top rather than ice forming at the bottom and freezing up? Turn with your pair-share partners and talk that out. Ready, set, go.
3,
2, 1, and go. Why is it important? Because the fish will die. So if the ice doesn't float, right, fish at the bottom of the pond will die. And we would have no fish anywhere where there would be ice. If ice doesn't float, you're going to have the ice from the bottom up and all those fish are going to die. Not even just the fish, anything in a pond is going to die. It says fish at the bottom of the pond will die. And it shouldn't even be really fish at the bottom of the pond because if ice starts down here and then it kind of gets solid and solid and solid and solid, everything would probably get pushed up and like you'd have fish like flopping out here, right? And then they'd be gone. Were we going to like restock lakes all the time? No, we would have no fish in areas like the northern hemisphere. That ice on the top gives a very protective layer. So it insulates the lake life, if you want to think about it that way. It insulates everything that's in the lake. Why does ice float? I have a bottle that is frozen and I have a bottle that's unfrozen. What's different about these two? What? Density, yeah. This one becomes less dense when you freeze it. Why? What changes?
Because it expands.
Yeah, because the volume expands out. So it's the same mass, but now it's taking up more space, and so it floats. So why does ice float? Same mass, but it, meaning water, expands when frozen, so it lowers its density. It's able to float that way. If water didn't have this absolutely critical property, we would not have the world that we have today. You just wouldn't. Of course, the Titanic would still be here probably, but, right, the life that we have today wouldn't. You wouldn't have nice ice cubes floating in your drinks. And that's because when they freeze in place, they are linked together with this positive, negative, positive, negative, positive, negative. And it becomes this crystal-like pattern that forces these molecules to hold their shape, which gives empty space in between the molecules, allowing it to go ahead and flow. Thanks, dear. You've got to grab the notes that you walked by. Oh, did you do that for them? No? Oh, you were already here? I marked you absent, so I'll try to remember not to change that. So the fact that ice floats is really important. If ice did not float, because even though the mass stays the same, it expands when frozen, so its density lowers, we would not be able to have fish or life in different ponds, especially in a place like Iowa. Just wouldn't happen. All right, let's move on. Right, not that, this. All right, water has a high heat capacity. This one wasn't a lab station, but it does go with vaporization. So can you go to station 7, please? Let's go to station 7 in your lab. Water has a high heat capacity. The first thing we're going to write at the top of this is, we're going to write that heat capacity is the ability, sorry, this marker's not very good, ability to absorb, which means take in, and hold onto energy or heat. So I'll say energy with my little symbol / heat. Because heat is just a form of energy. So if something's got a high heat capacity, it's got a great ability to absorb lots of energy and hold on to it. Does anybody here live in a very old house that has water heaters? Like those, the metal water heaters that are along the side of the house, in the inside? Cast iron heaters, like, you know, water goes through it and you hear the pipes go boom, 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 boom as it heats up. Do you know what I'm talking about? Water heater? Not a water heater that is in your basement, but like an old-fashioned water heater. Not like that. Water heater house? What do they call that?
Change antique to fashion.
Water heater for house.
If you
Not like
look
that.
up old-fashioned water heaters in Newark, because what we did was old antique.
I just think I'm calling it wrong. Oh, radiator heater. These.
Oh, those.
These. Do you understand what I'm talking about now when I say these?
Yeah.
Okay, so these are filled with water. And the reason, and I like that they call it a radiator because you also have a radiator in your car. And so I like that. So we're going to go ahead and use this concept of this radiator heat. All right. So The reason that those things are filled with water is because once you heat the water in there, water holds onto its heat for a really long time, and it's good at keeping your house warm for a long period of time. How many of you have ever wanted a macaroni and cheese and it takes forever for the water to boil? Yeah, that's because it's absorbing lots of energy, absorbing lots of energy, absorbing lots of energy before it starts to boil. It does take water a long time to boil because it has the ability to hold on to so much heat before it changes in temperature. The temperature of liquid water rises and falls much more slowly than most other liquids. Like alcohol just needs a little bit of energy and it evaporates or turns into a gas. It takes water an awful lot of energy before it turns into a gas. This is just a fun fact. A calorie, or CAL, is the amount of heat energy required to raise the temperature of 1 gram of water, 1 degree Celsius. You're going to do that when you get to biology. Hopefully they still do that for you in biology, when you figure out how many calories are in your food. In short, though, it takes a long time of water to heat up and a long time for it to cool down. We're going to talk right now about why it's important, why this is an important property for living systems by looking at your car. Your car has a radiator filled with water. What is the purpose of that water in your car? Turn with each other and talk about that. What is the purpose? What do we think? What's its job? Why do we put water in the engine? Yeah.
I want to say to keep it cool.
Yeah, it takes the heat off of the engine and it stores it inside of itself. And it moves this water, right, in pipes around your engine to keep your engine from overheating. That's why it's important. Your blood is like 90% water. So your blood, your circulatory system, works the same way. It cools your body down, as well as moving nutrients around, but it helps keep your body in what's called homeostasis, a nice, even kind of balance. Now, imagine this. You are almost dying from hypothermia, right? You know what that means, hypothermia?
Cool.
It means you've gotten really, really cold. Why is it that your fingers or your toes are going to be frostbitten first? With your pair share partners, see if you can figure that out. What happens to the blood in your fingers and your toes so that your fingers freeze? Turn and talk that out. What do you think? 5,
Your body pulls
4,
more of the blood.
3, 2, 1, and we are done. Why doesn't your blood stay in your fingers and your toes? Asa?
It tries to keep your core temperature.
Yeah, all the blood starts leaving your extremities, your little bits and pieces that hang out, because all of that goes inside to your internal organs, because you need your internal organs in order to live. You don't need your fingers or your toes or your nose or your ears in order to live. So your blood is going to go away from those items first, and it's going to try to keep you alive by holding all that blood inside, because it's trying to keep you inside warm. So while it also cools you, it also keeps you, again, at that nice level homeostasis. So it's really important that water is able to hold on to and absorb lots of heat and hold on to it for a long period of time. All right, let's turn the page on this one. This brings us to water has a high heat high heat water vaporization. What is this stuff right here?
Sweat.
Yeah. What is the purpose of sweat? With your pair share partners, talk that out. Ready, set, go. Everybody knows it cools your body down. So let's go ahead and write sweat cools body. But we don't know why it cools your body. And it's because of this idea that water takes a lot of energy in order to go from a liquid to a gas. You have to pump water full of lots of energy before it will go from a liquid state into a gas state. Hydrogen bonds, vaporization, let's write this up here. Vaporization just means liquid to gas. And for this to happen, it takes an awful lot of energy. So we'll just go ahead and put energy there. bonds between the water molecules require a large amount of heat to break. So water doesn't evaporate easy. It doesn't go to its gas form easy. This is important for living systems. As you said, it cools the body. But how does it do that? Turn with your picture partner and talk that out. This has to go from liquid, right? It has to go from liquid into the air. Get off of here, we don't want that. Into the air, right, or gas. Okay, this is your sweat over here. Is that sweat? And sweat is a liquid. And if I want the liquid to turn into gas or the sweat to go into the air, what does it require?
Energy.
Energy. Where does this energy come from in order to make this liquid turn into a gas and go into the air off of your body?
Excess body heat.
It comes from your body. So this energy comes from your body, and then what happens to the temperature of your body?
Cools down.
Your body then cools down, okay? So this drops your body temperature. Now, has anybody ever heard of humidity in the air?
Oh gosh, yes.
What does humidity in the air feel like?
Hot.
Very. It's like the air is like heavy, right, with moisture. The air is heavy. It's hard to almost to breathe. How many of you have ever exercised when there's high humidity? It's super dangerous. If there's close to 100% humidity, your body can't evaporate the sweat. What happens to your core temperature then?
Rises.
Yeah, it rises. Can your body get hot, hot, hot and not have any consequences? You can overheat just like a car and you can die. And you can die pretty quickly. We like to keep our bodies in homeostasis, nice and even. And it's kind of like this. If you have a pair of pants that you put on a clothesline to dry, and there's low humidity in the air, which means the air is not very full of water, it will dry very quickly. But if you try to put your pants on the clothesline to dry, and it's high humidity, those pants will not dry because there's no space in the air for that extra moisture to evaporate and go into the air. So you could like have those pants hanging out there or towels, for like all day, and they just won't dry. Some days you put it out there and a half hour later, it's dry because the air is really empty of water. So why is this important for living systems? Because it regulates our body temperature. Super important that we regulate body temperature. If you have not written down regulate body temperature, please do that. And this is how we regulate the body temperature. This is how. Why is it important for living systems? It helps us regulate body temperature. Regulate body temperature so you don't die. All right. Let's go to station 3, please. 2, station 2, water is a solvent. Go to station 2, please. Water is a solvent. Okay, a solvent is something that breaks apart molecules. Let's write that down. So solvent is really good at breaking apart molecules. Like water was really good at breaking apart salt, which is sodium chloride, okay? It dissolves or breaks apart a great number of solutes. So salt is an example of a solute. So let's go ahead and put this underneath here so you know that that's what that means. Salt is a solute. Sugar is another solute. Nail polish, did we talk about nail polish yet? Okay, y'all know what nail polish is, right?
Yeah.
How do you get nail polish off?
Acetone.
Okay, yeah, acetone or nail polish remover, people call that. Nail polish remover is the solvent, right? That takes apart, it breaks down the nail polish. So it dissolves in great numbers of solute, like salt, like sugar, and it can change their properties. This is how it does it. Notice again, we've got, what charge does chloride have?
Negative.
What charge does the atom sodium have?
Positive.
Okay, so then what side, if this is a positive atom, what side of the water molecule is surrounding it? What side? The negative side. The negative side. Oxygen is negative. We've got a negative here. We've got a negative here. We've got a negative here. And what it does is it puts a little pocket of water around this sodium, this sodium atom, so that it can no longer attach itself to this side of the chloride. And what is this? This is negative. It's attaching itself to what side? The positive. We've got a positive hydrogen, positive hydrogen, positive hydrogen, positive and positive. Because this thing is a polar molecule, it's very good at dissolving molecules into the separate atoms. And it keeps them separated because it makes this little pocket of water around them. So it like creates a pocket of water. I'm going to write that down. Creates pocket doesn't seem right. What would we say? Circle of water, pocket of water? Barrier of water, whatever. I'm just going to say pocket. You know what I'm talking about. Or packet, pocket of water around, boy, this is really hard to write with, around atoms. So it keeps them from coming back together again, unless you get rid of all the water. If you take salt water and you just leave it out for 5 days and all the water evaporates, what's at the bottom of the glass?
Salt.
All the salt. You couldn't see the salt before when there was water in it because the salt is dissolved in the water. This is what's happening. But then when all the water goes away, you've got now the salt crystals are able to come back together again. You can have the sodium and the chloride come back together and make table salt again. You see what I'm saying? Yes? Kind of? Okay. So then, again, this is important property for life because, water's really good at breaking things down, I guess. It is. It can, is it almost time to go? Oh, phew. It breaks things down, I guess. That's the best thing that I can see. It breaks larger molecules into smaller molecules. That would be a really important property of water. Larger molecules into smaller atoms. Okay, and that's how it does it. Let's turn the page. This is important. This is my favorite one. This is what we started with, and so this is kind of what I want to end with if we have time. Adhesion and cohesion. And this is freaking me out because I see it from the corner of my eye all the time, and I think that, I don't know what it is. But notice how you've got like the water molecules kind of like bonding and breaking and bonding and breaking, unless, right, that's what happens in water. But you've got them, the reason that this guy can stand on water is that adhesion or cohesion? Cohesion, because they're holding on to each other like this. This is what's happening with those water molecules. They're cohesion, they're combining, they're co-workers, if you want to think about it like that. So I'm going to say co-workers. Okay, so they're co-workers. They're working together. They're holding on to each other, that co and co. Adhesion means they're clinging to the sides of other things. Now, this is very important for why soil is able to transfer water through trees out into the atmosphere. We're going to talk about this. It's very good for capillary action. Hydrogen bonds create surface tension. So it's really nice for, little water striders like this that want to go ahead and live on top of the water. I think we did good with this one. Let's turn the page and talk about that last part. All right, the two properties of water that assist in the transpiration process are cohesion and adhesion. Transpiration means water evaporates from the leaves through the stomata. These are stomata. These are pores in the leaf. One water droplet at a time, one water molecule at a time will leave this. So I'm going to try to draw myself a little water molecule. One molecule at a time. It goes from the roots, and you get a water molecule that goes in there as this thing evaporates out because it's linked to what? This water molecule is linked to what? Oh, come on. This water molecule, because of cohesion, is linked to what? Cohesion.
Water.
Another water molecule. So as this one leaves, it's pulling another one into place. Okay? And so they're linked together. So what happens is they stick to the sides of these little capillaries, just like what we saw in our celery. They're going up the little tubes, and plants have these little tubes. And what's happening is the water molecule adheres itself to the side, and it's adhering itself to each other, which is drawing it up. So you get a lot of water every second of every day that leaves the geosphere. So this is water in soil, and it goes to water, H2O in atmosphere. You get a lot of water being moved, and this process is called transpiration. If you go out in the summer and put a little plastic bag around a leaf in your yard and tie it with like a little bread tie, don't leave it there, but like in 2 days, you'll see water that has collected in the bottom of the bag. And you can drink it. It's just water that has come through the tree and is now in that little bag. Transpiration. And if you estimate how many leaves that tree has and measure how much water was in that bag, you can estimate how much water is being transferred out of the ground, for that amount of time. Mm-hmm.
Is that why there's morning dew usually in the summer?
No, morning dew is condensation. Condensation is the air holding water and being taken out of the air. When you have glasses and you come in from the very cold into the warm, you have condensation on your glasses. That's basically dew. It's pulling it directly out of the air. There's water in the air right now. All right. This next one is just talking about acids and bases. I'm not going into acids and bases. They will talk about acids and bases when you get to chemistry. I don't know. Do you do that in biology?
What?
Never mind.
The bag and the leaf thing?
So we're going to go ahead and talk about acids and bases probably next year.
Do you do that?
Biology. Definitely when you get to chemistry.
Is the grain do that?
Yeah.
A little bit. Not too much.
Yeah. But again, it's all about like the positives and the negatives.
We do the bag and the leaf.
Yes, you did that one. Could you please turn that off? So tonight.